Hey, again, this is a no calculator, so I'm going to make the screen big. Okay. Question 4. It says, let f of x equal rad 3 e to the 2x sine x plus e to the 2x cosine x from 0 to pi, given that the tangent of pi over 6 is equal to, 1 over rad 3. We know that. He's on our chart. Thank you so much for giving us the most unhelpful clue ever, but perfect. Thank you. So let's go ahead and look at this thing, okay? Whenever you see something that is just like very complicated looking, I would try to attack it by pulling out a GCF and then doing zero product rule. I do see a GCF here, actually, believe it or not. It looks like the GCF is going to be e to the 2x. So I'm going to factor out an e to the 2x from each term up here and see what I'm left with inside of the parentheses, okay? So I have e to the 2x. This whole thing is supposed to be set equal to 0. So I'm like, all right, zero product rule, here we go. E to the 2x is my GCF, and I'm left with rad 3 sine of x plus, these cancel, cosine of x equals 0. Okay, that's not, like, truly not so bad. All right, so I've got my two factors here. I'm going to set this guy equal to 0, and then I'm going to set this guy equal to 0. Okay. This never is equal to 0. I will show you why. I know this is a no calculator question, but I just want to explain something. So I have e to the 2x. No, it won't give me to the x. Why is this not like fitting on here? This needs to go away. How do I make this disappear? There we go. Oh, wow. Okay, that's not what I wanted. This video is like 2 seconds away from being ruined. Okay, here we go. So I have e to the 2x. I graph him. And he never actually hits 0. Y equals 0 is the equation of his asymptote. He loves y equals 0. He wants to get to y equals 0 so bad, but he never will. He simps for 0. Hence his asymptote. But he'll never get there. So we're going to reject e to the 2x equals 0 because he will never get there. Okay. So then now I have rad 3 sine x plus cosine x equals 0. Whenever I see sine x and cosine x, none of them are double angles. I can't really turn them into one another. I'm going to think that it's tangent, okay? So what I'm going to do here is I'm going to move the rad 3 sine x over. I know, like, tangent is on my special trig values chart, so I'm going to want to turn this guy into tangent. That's why I didn't move the cosine over first, because then I'm going to end up with cotangent, and I'm going to have to flip it. So let's just try it this way. So now I have cosine of x is equal to negative rad 3 sine x, and then I'm going to do divided by the cosine of x divided by the cosine of x. So then now, careful, a lot of kids cancel this and then they put a 0, but it's actually 1. Equivalent quantities being divided equals 1. So then now I have rad, he's negative, sorry, negative rad 3 tan x. And I'm going to want to solve for tangent of x. So I have 1 equals negative rad 3 tan x. I'm going to divide both sides by the negative rad 3, and I now have negative 1 over rad 3 is equal to the tangent of x. And then look at that little clue that they gave us up top, right? They wanted to save you a bunch of time. So they were like, hey, the reference angle for 1 over rad 3 is pi over 6, which is actually very nice of them, and I don't think they would usually do that. But here we go. So they've given this to us, and they're like, okay, the reference angle for this guy is going to be pi over 6. However, this is for a positive 1 over rad 3. We have a negative 1 over rad 3. So that means we need to like consider which quadrant this guy is terminating in. All students take calc. Tangent is not positive, so we reject this, and then we are on the interval from 0 to pi. So that means we must be in quadrant 2. So the way that we figure out what a reference angle of pi over 6 in quadrant 2 would be is we scale up to the next irreducible fraction. So pi over 6, 2 pi over 6, he reduces. 3 pi over 6, he reduces. 4 pi over 6, he reduces. 5 pi over 6, he does not reduce. So we have 5 pi over 6 as our angle. So we have x is equal to 5 pi over 6.